Okay, for lesson 3, we are actually going to learn how to start conducting our first actual significance test. We'll go through the last pieces that we're missing, and then in lesson 4, we'll put everything we've learned together to be able to solve one large problem with what's called a one sample z test for proportion, but we'll get there later. So the next thing we need to look at is whenever we're trying to test against some null hypothesis. For instance, we were looking last class, I think, about the potatoes in the truck. And if more than 8% of potatoes in a truck are bad, we send it back. If less than 8% are bad, then we can keep the truck and make potato chips out of it. And so in order to, and then we take a sample from that truck to help us decide if we think 8% or more are bad. And so in order to actually conduct a test using a sample to make this kind of decision on whether we return the truck or not, we have to meet certain conditions for a test. And so to safely conduct this test, we need to meet certain conditions. I actually want a blue pen. Certain conditions must be met. If the conditions aren't met, then the test that we actually go through all this work to conduct might not actually be valid. We can do the math and get an answer, but it might not be a very valid answer. It might not actually be meaningful statistically. And that's why when we often read about studies, we want to make sure that these conditions are met because they sometimes come to conclusions that aren't actually valid. If a condition isn't met, then sometimes we choose to assume that it's met. That seems pretty sketchy. We just let's just assume it's met. Well, we just want to state that we're assuming that. We want to be honest. We are assuming it's met, but then we want to proceed with caution. We want to let whoever is reading our work know that that condition wasn't met, so we had to assume it was met. And so take these results that we have received with a grain of salt, meaning that they're okay, but just know I didn't quite meet all the conditions. And so that's why I call these conditions or assumptions. And for the test that we're going to look at today for proportions, we're going to look at tests for proportions today. We have 3 conditions. And the 3 conditions are we must have randomness. There's a 10% condition, which means the sample size has to be less than 10% of the population size, and large counts. Our samples in relation to the proportion, the null hypothesis proportion, the sample size have to be large enough. We have to have a large enough sample size to actually justify the conclusion that we make. And we'll go through an example with this first. But these are our 3 conditions. First, the data come from a random sample. We need to know that the sample was randomly taken somehow. And it has to be from the population of interest. So the sample should come from the population of interest. And we can usually read that in the whatchamacallit, in the problem. Population of interest. Did I spell interest right? I think so. Okay. 10%. When sampling without replacement, n has to be less than 0.1 n. Well, we have 2 n's here. Lowercase n stands for the sample size, the size of the sample that we're actually collecting. Uppercase N is the population size. And so lowercase versus uppercase means something slightly different. The sample versus the entire population. And what this is saying, feel free to write this down, the sample cannot be more than 10% of the population size. The sample cannot be more than 10% of the size of the population. Next, we're going to have to do a little bit of calculations. We need the product of the sample size plus the null hypothesis, the parameter, and also the sample and 1 minus the null hypothesis. Both have to be at least 10. We'll see again what this means in an example below. They must be at least 10 or greater than or equal to 10. Same as greater than or equal to 10. Okay, so those are our conditions. We'll check those in the first example that we see next.